Hello everyone. Hi. So join quickly, we'll start. So today we are going to again discuss power plant engineering for BARC 2024. Okay. So BARC level, PSU level question we are going to see. Is my audio and video clear? Can you confirm if my audio and video is clear? Can you please confirm if my audio and video is clear? Then we'll start. करें? Okay, thank you. Chalo, let's start. Before we start, just quick introduction. So guys, I have 6+ years of teaching experience. I have taught for GATE, ESC, AE, JEE and other exams as well. I have done my MTech from IIT Kharagpur, MSc from Politecnico di Milano. Some research experience, 3.5 years of research experience. Few research publications as well. And my area of expertise is basic and applied thermodynamics. Okay, chalo. So, as you already know, I have been announcing this. If you are targeting GATE 2025, then Anil Prasad sir is, just one second. Anil Prasad sir is coming up with this workshop on the app on 13th of March. So you can join this app and join this workshop if you are targeting GATE 2025. Also, if you want to join Vision batches, then there is a scholarship test on 10th of March. Okay, 10th of March, you have a scholarship test. You can get from 10% to 90% of a scholarship. Okay, so if you want to prepare and you have financial issues, then you can go for this test. Okay, chalo, again your scholarship test on 10th March. Anytime you can take it during the day. If you have not joined, do join the Telegram channel Mechanical by Vipin Yadav, or you can scan this QR code, you will be redirected. ठीक है? करें start? चलो. Let's start with the very first question for today of power plant. ठीक है? See this. The moisture content of a steam at the turbine exit of the steam power plant. Steam power plant means Rankine cycle. Okay. अच्छा लिखा भी हुआ, it is on the Rankine cycle can be decreased. If you want to decrease moisture content, that means mass of liquid, if you want to decrease, what can you do? How can you reduce the moisture content at the turbine exit? How can you reduce? What is the right answer? So if you draw TS diagram, it's drawn something like this. So let us say this is 1, 2, 3, 4. Now the first option is telling you, decreasing condenser pressure. That means if you decrease this pressure, then you can see the amount of moisture is increasing, mass of liquid is increasing. But you want to decrease it. Okay. If you are increasing boiler pressure, then what will happen? If you are increasing boiler pressure, that means you will go like this. Because again, your maximum temperature cannot increase. Because of material restrictions, it is fixed. So here also you can see that your moisture content has increased. moisture content and increase. Reheating. So if you are doing reheating, how will you do reheating? You will do on the same cycle. Expand, come back, expand again, and then, so now you can see your moisture content is reduced. Subcooling steam, I don't know what is subcooling steam. Okay, so the right answer is if you are reheating steam. So reheating is actually done to reduce the moisture content. Yes, right? Reheating is actually done to reduce the moisture content exit of the turbine, because turbine cannot handle more than 15% of moisture at the anywhere, but you have to limit it to below 15% at the turbine exit. Okay, chalo, question number 2. The pressure ratio of the gas power plant means Baraton cycle, corresponding to maximum work, यानी कि I have to find out P max by P min for maximum work. How do you give it? How do you give it? How do you give pressure ratio in a Baraton cycle corresponding to maximum work output? So it is written as how? T max by T min upon gamma upon 2 gamma minus 1. Yes or no? Yes or no? So which option is correct? Gamma upon 2 gamma minus 1. C is correct. Yes? Come on guys, you have to participate in the chat. Otherwise there is no point. Yes? Yes or no? चलें आगे, चलें आगे, चलो. Question number 3. The power developed by a turbine in a certain steam power plant. Steam power plant, we have already seen the diagram. Yes, is this, यानी कि turbine output. This turbine output is this turbine output. This is pump work input. This is heat added. This is heat rejected. Okay. So what is given? Turbine output is 1206 kilowatt. Heat supplied is 3500 kilojoule per kg and heat rejected is 2900 kilojoule per kg. Feed pump work is given as 6 kilowatt. Mass flow rate, you have to find out mass flow rate. So you can do it by calculating efficiency also, or simply we know for a cycle, summation of Q is equals to summation of W. So Q in minus Q out is equals to work of turbine minus work of pump. And anyway, this is small q. So this is mass flow rate, small q in, small q out is equals to work of turbine minus work of pump. Mass flow rate 3500 minus 2900. कितना आ रहा है आंसर? What is the answer? Mass flow rate is equals to कितना आएगा? 1200 by 600 is equals to 2 kg per second. 2 kg per second. Yes, आ रहा इतना? आ गया? चलें आगे. चलो. Dry saturated steam at the pressure of 8 bar enters the convergent nozzle. So entry, if nozzle is there, P1 is 8 bar, P2 I don't know. The index of isentropic expansion यानी कि N is equals to 1.135 for maximum mass flow rate to occur through the nozzle, the exit pressure. Exit pressure. What is the condition for exit pressure? P2 by P1 is equals to T2 by T1. What is the condition? What is the condition for maximum mass flow rate in nozzle? P2 by P1 is equals to 2 by T1. Quickly guys, quickly answer. N upon N minus 1. Yes, N upon N minus 1. And temperature is also not given. Temperature is also not given. So how can you write this? Is equals to 2 upon N plus 1, N upon N minus 1. Now you know everything. Of course, you cannot solve this without calculator, but they will give you some values in this if they ask. Otherwise, it is same for everyone. You can't do anything. This is 1.135 upon 0.135. कितना आ रहा है आंसर? P2 by 8 bar. So you will get P2 as how much? Of course, you will get less than 8 because it is 2 upon 2.135 1.135 by 0.135. कितना आएगा? How much is the answer? It will be less than 1, of course. And then you multiply it by 8. So it will be P2 is equals to 4.62 bar. Yes. Chalo, next. Which of the following helps to increase efficiency? You have to increase the efficiency of the Rankine cycle. Efficiency of the Rankine cycle. How do you increase the efficiency of Rankine cycle? Increasing average temperature at which heat is rejected to the working fluid. Increasing average temperature at which heat is transferred to the working fluid. Increasing the condenser pressure operating at constant temperature. क्या होगा? Efficiency is what? Efficiency is of Rankine 1 minus T lower by mean temperature of heat addition. Mean temperature of heat addition. So if you want to increase the efficiency, you have to decrease this. And how will you decrease this? By increasing mean temperature of heat addition. Because T lower is fixed by atmospheric conditions. You cannot go below atmospheric conditions. So what is the right answer? If you increase condenser pressure, then T lower will increase and efficiency will decrease. Okay. If again T lower if you are going to increase, efficiency is going to decrease. So basically the option is B. Yes. Very simple question. Single stage impulse turbine is known as single stage impulse turbine. Quickly guys. Single stage impulse turbine. Velocity compounded impulse. Pressure compounded impulse. 100% reaction. 50% reaction. Tell me quickly, what is single stage impulse turbine? What is single stage impulse turbine? Single stage impulse turbine is Curtis reaction, the level or at you. Come on. Guys, you have to know this, okay? PSU, they ask this question. Very common question. Single stage impulse turbine, what is the right answer? Okay, let's start from here. This is Parsons. This is Heroes. This is Retu. This is Curtis. And what is this? The level. Have you not done this? Come on. Have you guys not done this? The level, the level. Yes. चलें आगे. चलें. Compounding of steam turbine is done too. Compounding. Why do we do compounding? Why do we do compounding? Because the amount of pressure ratio that we actually want for our practical applications, for that the rotor speed is really high. Rotor speed is really high. By compounding, we can actually reduce the rotor speed. I mean, our turbine cannot operate at that kind of speed. So what we do is, we reduce this pressure in stages. That's why we do compounding, okay? So reduce the rotor blade. That is the main reason. Reducing work and producing more work is not the reason. Reducing the rotor speed is the main reason for the compounding. Okay? Chalo. Next question. In a nozzle, steam is flowing. If the back pressure PB is equal to critical pressure, then mass flow rate of the steam is. What is the mass flow rate? What is the mass flow rate? So in the nozzle, let us say this is P1, this is P back pressure. So when P1 is equals to PV, there is no flow, yes? When back pressure is reduced, then flow happens, flow starts. So mass flow rate increases. And when not equal actually, when P1 is greater than PB, and then PB keeps decreasing, and when it becomes to critical pressure, mass flow rate becomes maximum. Because if you even further reduce PB, your mass flow rate will not increase. Mass flow rate will be maximum. Mass flow rate will be maximum when the pressure is critical pressure. when the pressure is critical pressure. Okay, so it is maximum, mass flow rate is maximum. In very detail we have studied this in our classes. ठीक है, चलिए अभी just now we have done this. You have to answer this. Degree of reaction for Parsons reaction turbine is, what is the, abhi just now I told you here, what is the degree of reaction of Parsons? What is the answer, guys? डिग्री ऑफ रिएक्शन कितनी होती है पार्सन्स की? 50%. यस, 50%. वेरी गुड, सही है. नेक्स्ट, चलें आगे. Maximum efficiency for a single stage pure impulse. Maximum efficiency for a single stage pure impulse bleeding with nozzle angle alpha is given as. Guys, you have to know this. If you are sitting for BARC, then power plant is one subject that they ask so many questions from. Not just any PSU. You go to any PSU, power plant is the maximum weightage subject. Even if you see ESC, so many questions they ask from power plant. Okay, and you can take any, even SSC, JE, AE, PSU, any PSU you take, power plant is the highest weightage subject. So if you are neglecting power plant, it's not same as gate. Gate may they do not ask power plant that much, but in PSUs, power plants, even if you combine basic thermodynamics, IC engine, RAC, their combined weightage is less than the weightage of power plant. So power plant you cannot neglect. Power plant you cannot neglect. You have to study power plant. कितनी है efficiency? Maximum efficiency is cos square alpha. है या नहीं? We have derived this. We have derived this. Okay. If you are not participating, there is no use of this. I am telling you. Okay, so you have to participate actively. Otherwise, I seriously, I see no point. I have other classes scheduled. I can just cancel it. Okay, so please participate. Then only it is useful for you. It is not of any use for me. Simply. Okay, chalo. Very simple question. This we have done for maximum work output in expansion or minimum work input in multi-stage compression as well. So we know that for maximum work output in two-stage expansion gas with perfect gas intercooling, perfect gas reheating, it should be reheating, right? If it is expansion, it is reheating. If it is compression, it is intercooling. So this is reheating. The intermediate pressure P has the following relationship between so we have to find out, sir, what is this intermediate pressure? If this is P1, this is P2, then what is this P? When you get the maximum work output, when you get the maximum work output. So we have derived this. And this is intermediate pressure is equals to P1 into P2. P1 into P2. Yes, even for compression also it is same. Okay, if you want minimum work input for multi-stage compression, then what is the intermediate pressure? Under root P1 into P2. Yes? Chalo. Next. air is compressed in a single stage reciprocating compressor at the rate of 1 kg per second. Mass is equals to 1 kg. From P1, this is your P1, this is your T1, this is your P2. Okay. If gamma is equals to 1.4, R is equals to this, and this value is given to you, and ln 8 is this. Difference in work required if compression is isentropic and isothermal. So you need to know those formulas. I hope that you know those formulas. Okay. How do you calculate work when isentropic process is happening? This we have derived. And when isothermal is happening. How do you calculate this? We have derived this equation. Do you remember? Gamma upon gamma minus 1. Yes. Gamma upon gamma minus 1. P1 V1 P2 by P1. Sorry. माइनस 1. इसमें क्या है? P1 V1 ln P2 by P1. Yes. Calculate this quickly. How much is this? You need to find out V1. You need to find out V1. Okay, here you will get this as well. Gamma minus 1 by gamma. Sorry. What do you need? Gamma, you know. Gamma is given 1.4, 0.4. P1 also you know 1 bar. Yani ki 1 into 10 to the power 5. Sir, V1 I don't know. How do you calculate V1? Arey Baba, you know everything. P1 V1 is equals to MR T1. Air is there. V1 is equals to mass is how much? 1. R is 0.287. T1 is 22. 22 is 295 upon 100, because pressure is 100 kilopascal. So this I have taken kilojoule, this I have taken kilopascal. You will get V1 here. V1 you can substitute here. Then 8 by 1, 0.4 by 1.4 minus 1. And here also you can get 1 into 10 to the power 5. Into V1 you have to substitute ln 8 by 1. Kitna aega? How much do you get? Net work is equals to W isentropic minus W isothermal. If I remember it correctly, I think you will get 64 net work. This I think you will get. Let me check actually. Yeah, net is 64. Very good. Okay, so you have to solve it. Okay, and again you would not, if you calculate V1, I don't know how much is V1, you can substitute it here. This value is given to you. See, this is already given to you, and ln this is also given to you in question. So this is how they will give you these values. Okay, mostly if you cannot solve it from calculator, they will give you those values. Otherwise you are supposed to solve them in fraction or something. But either you should be able to solve it without calculator, or they will give you that term. Okay, so you should be able to solve this. Otherwise, if you are not able to solve that, it's same for everyone. You can't do anything. Volumetric efficiency of a reciprocating compressor is not dependent on the following factors. वॉल्यूमेट्रिक एफिशिएंसी किस पे डिपेंड नहीं करती है? किस पे डिपेंड नहीं करती है? 1 प्लस सी माइनस सी P2 बाई P1 1 बाई n किस पे डिपेंड नहीं करती है? कि दिस इज क्लियरेंस रेशियो, दिस इज प्रेशर रेशियो, दिस इज पॉलीट्रॉपिक इंडेक्स. किस पे डिपेंड नहीं करती है? एयर रिसीवर पे. हाउ मच एयर इज रिसीव्ड इट डज नॉट मैटर. ठीक है, क्लियर है? चलें आगे. चलें. चलो नेक्स्ट. If the compression of the air is carried out in large number of stages with perfect intercooling between the stages, then the overall compression approaches. What does the overall compression approaches, bhaiya? So you see, this is your actual process and this is your compression. TS diagram. This is your compression 1 to 2. But if you do not do it like this, you do it how? Multiple stage intercooling. Okay. So compression intercooling, compression intercooling, compression intercooling, compression intercooling, compression intercooling, and compression, and then you expand it like this. So now you can see here this process is basically at almost the same temperature, T1 is almost equal to T2, and now it is not isentropic. What is it? It is isothermal process. Yes, isothermal process. So whenever multi-stage compression is done with perfect intercooling, it represents a iso, or it can approximate a isothermal process. Similarly, you can do the same thing. Multi-stage expansion, reheating, expansion, reheating, expansion, reheating, expansion, reheating, expansion, reheating, expansion, reheating, and then you can reject heat. So this is again, this is at constant temperature, 3, 4. T3 is equals to almost T4. ओके चलो. In two-stage reciprocating air compressor, suction, we have two-stage reciprocating compressor. Okay, suction pressure is 1 bar, delivery pressure is 4 bar. Maximum efficiency, the intercooler pressure यानी कि intermediate pressure is how much? P1 into P2. Very simple question. 1 into 4 is equals to 2 bar. Yes or no? Yes. Correct? चलें आगे. चलो नेक्स्ट क्वेश्चन. Which of the following is true for performance parameter of vapor power cycle? Which relation is good? By work ratio is equals to net work यानी कि turbine work minus compressor work by turbine work. So you can also write 1 minus compressor work by turbine work. Back work ratio is equals to compressor by turbine. So you can substitute it here. Work ratio is equals to 1 minus back work ratio. What is the right answer? C is the right answer. 1 minus back work ratio. You have to know these. Most of the questions are formula based. Okay, most of the questions are formula based. If you do not remember the formulas, you will not be able to do it. Just theory will not work. Most of the question you need to know the formula. At least one step solution or two step solution, or directly formula based. But formula you must remember. That there is no other choice. Okay, no other way. Next. So this we have already done. Tell me what is the answer. This we have already done. What is the answer? Question number 17. Pressure ratio, known for critical pressure ratio for maximum discharge of the nozzle. In the beginning we did this, right? Tell me quickly. What is the answer? We have done this earlier. Answer is A. Okay, we have done this. Benchmark pressure above which boiler is considered to be high pressure boiler. When do you say that it is a high pressure boiler? What is the benchmark pressure? 60, 80, 100, 120. 60, 80, 100, 120. What is the benchmark pressure to be classified as high pressure boiler? To be considered as high pressure boiler. It is कितना है कुछ आइडिया? What is the benchmark pressure? Any idea? Any guess? You don't even have to remember the formula. Just guess. What do you think? Just give me a guess. The benchmark pressure above which a boiler is considered to be high pressure boiler. What do you think? So, the answer is, what is the answer? It is 80 bar. 80 bar. Come on guys, you have to know this, okay? These are very basic things that you need to know if you are sitting for BARC or ISRO or any PSU for that matter. Lancashire boiler has dash flue tubes while Cornish has dash flue tubes. Lancashire and Cornish are water tube or fire tube boiler? They are fire tube boiler. So they have flue tubes. How many? Lancashire has 2 flue tubes and Cornish has 1 flue tube. So 2:1 is the correct answer. Operating pressure for once through boiler is. So I hope that you know we have classified our boiler as subcritical and supercritical. So here we have all that economizers, reheater, superheater. Here we do not have anything. Okay, it is just it goes once and water will be converted to steam. Okay, not because they work. Because these work above supercritical and these are called as once through boiler. Just passing by the boiler once, it will be converted from water to vapor. You don't need economizer, reheater, superheater, nothing is required. Okay, it is called as once through boiler. Once through boiler. ठीक है? चलो. So it is supercritical. Supercritical. Pick the correct example of fire tube boiler. Which one is fire tube? Which one is? Just now I told you here. Lancashire Cornish is fire tube. Okay. Now tell me out of this, which one is fire tube? So as you can see, Cochrane is the only fire tube. Otherwise, Benson, Lamount, Wilcox, Lancashire, sorry, not Lancashire, Lancashire is not, Velox, these are all water tube boiler. Sterling, water tube. Okay. A is the correct answer. Dash boiler is an example of once through boiler. Just now we have talked about once through boiler. Once through boiler is the boiler that works over supercritical. Okay, what is above supercritical? What is the pressure? It works greater than 22 megapascal. Greater than 22 megapascal. Okay. Chalo. So which boiler is an example of once through boiler? Do you know this? You have to know this, guys. Benson boiler. Benson boiler is the example of once through boiler. Lamount and all, these are not. Okay. Chalo. While classifying the boiler into fire tube or water tube, mark the odd one out of the options. So we have to find out the odd one out. यानी कि either one will be water tube, rest will be fire tube, or one will be fire tube, rest will be water tube. So tell me quickly. Cochrane locomotive, Stirling, Lancashire. I guess I just told you Cochrane locomotive, Lancashire, they are all fire tube boiler. They are all fire tube. Stirling is a water tube boiler. Water tube. So the only option that is odd one out is Stirling boiler. Okay. Chalo. Dash cannot be counted as boiler mounting. So what is the difference between mounting and accessory? Mounting and accessory. Mounting is used for safety purposes, and accessory is to improve the performance or increase the efficiency. So all the economizer, superheater, reheater, they are all accessories. Okay, but other, for example, pressure valve, feed water, fusible plug, stop valve, they are all mountings. So pump is not, blow off cork is a mounting, fusible plug is a mounting to avoid overheating, stop valve is a mounting, feed water pump is not a mounting. It is not a mounting, it is an accessory. It is a accessory. Okay. Chalo. Let's go to the last question for today. A portion of water is discharged when the boiler is in operation to blow out mud, scale or sediments periodically. What do we call that? Feed check valve, fusible plug, safety valve, or blow off cork. So guys, blow off cork is used either to, if you want to empty, for example, you want to empty the boiler for maintenance, regular maintenance after 6 months, 7 months. So then you can blow off all the water, or if you see a lot of mud and sediments in the water and you want to remove that water, then also basically whenever water has to come out, it will come out through blow off cork. It will come out through blow off cork. So either you want to do maintenance, then also you will remove the water from there, or if you want to remove the salts and sediments and mud and everything, then also remove water from this. Okay. So blow off cork is used to discharge water from the boiler. Okay. So I hope it is clear. Chalo. If you have not joined the Telegram group, do join the Telegram group Mechanical by Vipin Yadav, and you can also scan the QR code. Okay. If you want to join the vision batches, guys, so already started GATE 2025, a very structured course. You will have live classes, recorded lectures, study material, practice, daily practice quizzes you will get, and mock test. And if you want to get any information about this, you can call on this number for one-to-one counseling, or you can fill out there in the description box. There is a counseling form you can fill out and they will call you back. Okay. Chalo, very good. So let's stop here and I will see you very soon. So we have RAC and IC engine left. that we will finish for BARC. Okay, and I will see you on Tuesday and Wednesday. ठीक है, चलिए, let's stop here. Bye bye.